All right, so back to it. Believe me, kids, I am tired and don't want to do this, so I don't want to hear your excuses. Heck, I had to make it. I sat down here in what we call the narthex. Well, anyways, it's the room outside the sanctuary at church, and made this while I was waiting between Bible study and church to start. So yes, I even took math to church. All right, 6, solve this equation. I want you guys to be very comfortable with this rule, and the rule is that the rth root, r for root, of some x to some power is equivalent to x to the power over the root. P stands for power, r for root. So when I glance at this thing, this is my power. And this bad boy right here is my root. All right. For anything besides the square root, this is how you do it. I'm going to type in 3x minus 2 raised to the 2/5 into y1, and then minus 5. That doesn't have the exponents. That gets sick, kids, sometimes. We're going to type in this polynomial into y2. I couldn't tell you how many answers this thing has. I also don't think we're going to have to do a window adjustment. Roots are usually arms, although this is a 2/5 power, so who knows. I just hadn't paid enough attention to them to catch on to patterns. Anyways, that gets roof-topped to the 2/5, and then we're going to take away that 5. That's my y1. 2x to the 4th minus 4. Zoom 6. Always do a zoom 6. Sorry about that glare. That'll be the root function. Kind of a funky looking function, isn't it? There's two intersections. There's one here. There's one here. There's no window adjustments are needed. So it's just a second trace 5 intersect. Get close. Enter, enter, enter. There's one at negative 0.7970. Sorry, 71 if I round properly. I don't care about the y values, I'm just finding x's. And there's another one right here, so I hit second trace 5 intersect. I move my cursor to the right, enter, enter, enter. And there's the other one, x equals 0.3164. There's another exponential equation. It's y2. You could type it in just as it appears, 2e to the 3x minus 4. E is a number that is really important in this world. A man named Euler, who spent a good bit of his life trying to figure out what it was, he was brilliant, and it was something he noticed that was in nature. It was a pattern he caught on to. What is E? E is the limit as x approaches infinity of 1 plus 1 over x to the x. You guys have no idea what a limit is, but it basically means you keep plugging in bigger and bigger numbers. It is approximately 2.72. That's roughly what it is, 2.72. But anyways, you don't even have to know that. You just have to know where the E button is. There is an E button. If you look at this, which is natural log, and you'll see it in blue, so second ln brings it up. And, you know, one thing that I want to talk about is kids are going to want to be like, Mr. Milbrath, where's that E button? You have eyes. God gave you a pair of eyes. Just look. It's there. Unless you're colorblind. I could see that. But you would still see it. It just wouldn't be blue. So anyways, y1 and y2 are done. Zoom 6, you're going to have to look up. You know, if you see that 12 there, you know you're going to have to look up. Your y max, we'll just set it to be 15. So window, y max down to 15. Graph. Now I should see the intersection. Second trace 5. Get my little cursor close. Enter, enter, enter. And the x value is about 1.9306. All right, moving on to 8. That'll be the last of the new stuff. Solving what we call a rational. Remember, a ratio, a over b, fractional equation. And you don't really have to do anything special on these. I'll show you how to put fractions in, but you don't have to. You could actually just do x minus 2 times x plus 1 divided by 2x minus 1, and it'd be fine. Or you can type it in just as it appears. x minus 2 times x plus 1, sitting over twice x minus 1. On every calculator that any of y'all are going to use, if you want to bring up an actual fraction symbol, you go to Math. Remember, you feel num, so scroll to num. And it's right at the bottom. Notice I hit the up arrow. You can scroll down. It'll take you a few seconds of your life. But if you scroll all the way down to the bottom, you'll see n over d. And that'll bring up the actual fraction symbol. Then you just type it in as it appears. There is a shortcut on my calculators. There is not a shortcut on maybe Cantrell's or Garner's calculators. But mine are the newest set, so they have a shortcut. And I'm just typing it in as it appears. You actually don't need fractions in the denominator, but so be it. And y2 was negative 3x plus 5. Then again, we do zoom 6. So there is the rational function. All rational functions are funky. And there's two intersections. So no need for a window adjustment. None. Second trace 5. Take a cursor, get it close. Enter, enter, enter. One of my values is 0.2441. Back to second trace 5. Take my little cursor, get them close. Enter, enter, enter. And there's the other one. 1.7559. Then we have some old stuff to do. Make sure you read little boxes like that. So at 1,820 feet tall, the CN Tower in Toronto, Ontario is the world's largest self-supporting structure. That was taken from somebody else. Suppose you are standing in the observation deck at the top of the tower and you drop a penny from there and watch it fall to the ground. Thankfully, due to air resistance, it won't be going as fast as it should be. The table below shows the distance from the ground after various periods of time in seconds have passed. Where is the penny located after falling for a total of 10.5 seconds? It says quadratic model. So I'm going to have to put this in the calculator, do a quad reg. I'm going to go to Stat. I'm going to go to Edit. X, which is your time, because time is always X, goes into list 1. And your distance, Y, goes into list 2. This is always, the first column is always X, second column is always Y. So Stat, Edit. All right. Now I'm going to press the Stat key. I'm going to go to Calc, and because it's a quadratic, notice the quad, I'm going to choose Quad Reg for quadratic regression. So Stat, Calc, quadratic regression, number 5. Scroll down to Calculate, and there she is. This is my equation. Y equals negative 16x squared. You shouldn't be surprised by that, because we've done a lot of equations. There is plus 0 and there's no x, so plus 1821. And we're supposed to use this model to determine how far off the ground the thing is in 10.5 seconds. So I'm just going to plug the 10.5 in. Y sub 10.5 is negative 16 times 10.5 squared plus 1821. 57 foot. Nice little problem. Wow, I think it takes up the whole page. You have to study the relationship between the monthly e-commerce sales and the online advertising cost. You have the survey results for 7 online stores for the last year. Your task is to find the equation of the straight line, which is y equals mx plus b, that fits the data. And after you do that, estimate the monthly e-sales if the advertising budget is $3,000. Now notice the online advertising dollars is in thousands. So this is actually just 3, as in 3,000. So it's going to be the same. We're going to go to stat. We're going to put all the crap in. This will be my x's. This will be my y's. Okay. And after done, we're going to go to stat, calc. We're going to do linreg, or linear regression. We're going to do ax plus b. Stat, edit, clear out your list. Don't be the guy who presses the delete key. And this is just nothing. Okay. What matters, that's what we call qualitative data, not quantitative, because it's a quality, it's not a number, at least a number that's usable. It's just the number of stores. 368, 340, 665, 954, 331, 556. Okay, looks good. 1.7, 1.5, 2.8, 5, 1.3, 2.2, 1.3. Anyways, I'm pretty sure all y'all can do that. Stat, calc, linear regression. Scroll down to calculate. Bam. There she is. I think it says along the top on this sheet that everything should be taken to 4 decimal places. So I is 0.0056x minus 0.6180. Because I said 4 decimal places, right? That's what I said. Anyways, you want to know what happens when you plug a 3 in. 0.0056 times a 3. Something seems wrong. Something seems seriously wrong here. Oh, I'm a moron. This is the independent variable. This is the dependent variable. I am so accustomed to the first column being x and the second column being y that I just went with it. But then it wasn't until I wrote an equation that I went back and thought it looked kind of funny. This is wrong. I hope you caught that before I did, because I missed it. So let's do this again. Anyways, the big numbers in this example go into y2. And the little ones, I hope that makes sense. I should have thought about it before I did it. But your independent variable, which determines your outcome, is always x. So this ought to look a whole lot better. All right, assuming there's no typos there. I'm having one of those days. That looks pretty good. Anyways, back to stat, calc, linear regression. There we go. That equation makes a lot more sense. So y is 171.4656x plus 125.8349. Now, I want to figure out what happens when I plug the 3 in, so I'll plug the 3 in. Get out of that, 171.4656 times the 3 plus 125.8349, 640.23. And you can kind of see that they're just rounding over here to the nearest whole. So that's fine. 640 thousandths, that's cool. So $640,000. 1, 2, 3. This is what matters. Some of you guys will get what that number is, some of you won't. So it pays to advertise, apparently. Well, it seems so. All right, immigration problem. The number of foreign-born immigrants in the United States has fluctuated over the last 100 years. Below is a table that gives the number of immigrants in millions for years since 1900. So you can see we've always had immigrants. It's just the way it is. T is the time since 1900, so hence why it's 0, 10, 20. This would be 1920, and this would be the year 2000. All right. Notice it says create a cubic model of best fit. So time is my x, population is my y, and it's the same deal. Stat edit. It's going to be the last problem I do. After this, I've got to make some copies because it's Monday, and Algebra 2 kids have a test, which means Mr. Milbrath is going to spend all day grading papers. Oh, I hope they're good. May your test scores be good, because then I'll be happy. Hopefully a lot of y'all take the Ocho version, so at least you get an 80 maybe. Maybe, I don't know. There'll be kids that don't. All right, so I'm going to scan to make sure there's no typos. It's the only way you can miss these. That looks good. It wants a cubic model, so stat, calc, cubic, regression. Stat, calc, cubic, which is number 6. And there she is. The equation is 1.3873x cubed minus 0.01667x squared. Oh, I didn't see that right there. E to the negative 4 is equivalent to 10 to the negative 4th power. This is saying shift the decimal 4 left. So we're actually going to have to go out 4 significant figures. 0.0000139. That's, by the way, something you learn in science with a teacher you guys like a whole lot more than me. Minus 0.01667. I don't need that one there. I need that to be a 7. Just erase that. I am way too tired to even write today. 0.0167 x to the second plus 0.4873 x plus 10.1944. So there is a model of immigration in this country. And we want to predict the population in 2023. Well, this would be time is 123, right? So everywhere I see an X, I'm 123. But I don't need one there. And I am not wanting to write all that down because I just really don't feel like doing it. Plus, I'm short on time. And if I make a typo, so be it. And evidently I made a typo. Because that shouldn't have happened. I can tell you exactly why it happened. I know exactly why it happened. It's right here. Too many zeros. 0.000139x cubed. Man, that stinks. Just so I don't mess up, I'm going to take 123 and I'm going to store it to x. That looks better. Also seems reasonable based on what Fox News tells you. But anyways, the outcome here is 76.1. I'm going to go with the same rounding they do. Million. You know, depending on what news you watch, that definitely seems like a reasonable answer. If you watch Fox, yeah, it's reasonable. If you watch CNN, you know, what? Immigration. Just depends on who you watch. All right, so I'm done with that. Sorry about the mistake on the last one. I need to wake up before I do some more.